In this video, we're going to take a look at some of the basics, equations, and applications of Bernoulli's principle. Hopefully, at the end of this presentation, you will be able to apply your new skills and knowledge towards the following videos in this series. Some things to keep in mind as we progress through this topic are that this principle is very important in our fluids unit in that it relates pressure to speed and height. This ultimately means that the pressure on the affected object is greater at the bottom as opposed to the top. And, as always, the conservation of energy still applies. Our equation for today is as follows. I'll pause for a second to allow you to comprehend it. On the left side of the equation, you will use your initial data to complete the equation. Likewise, you will use the final data to complete the right side of the equation. And remember that energy is conserved. In this diagram, it shows a faucet and a pipe that runs 20 meters upwards. As indicated by the arrows, there are different pressures and volumes at the different levels. This is the typical type of problem you will see when you apply Bernoulli's principle. One of the most common applications of Bernoulli's principle is something that you've most likely experienced yourself. This, of course, would be in aviation, where the principle uses air to create lift around the wings of a plane. The curvature of the top of the plane's wing forces air to move more rapidly across its surface. The pressure deficit on the flat bottom of the wing creates lift. Another application of this is evident in ballparks across America. When a pitcher throws a curveball, he pitches in a manner that puts the ball into a rotational pattern that, much like in the situation of the plane's wings, creates higher air pressure on the top of the ball and lower pressure on the part of the ball closer to the ground. This alters the flight path of the ball, hence creating the curve in a curveball. When solving a problem regarding Bernoulli's principle, it is important to first write down any and all given variables along with the equation. Next, you want to eliminate any terms that equal zero in your newly established equation. Use your foundation of algebraic skills to solve for the variable you're looking to find. There are also a few equations on this slide that you may want to take note of because they are commonly used in conjunction with the equation we just went over. A few helpful reminders that may come in handy when solving are that if the container you're working with is open, use atmospheric pressures constant. Also, you may want to record this constant for frequently used densities. Hopefully this presentation has helped your comprehension of this topic. Feel free to reference the other two videos in this series for more information and applications of Bernoulli's principle. Thanks for watching.